Well, thank you very much. It's a great pleasure to address your discussion forum. And I see I have a mistake in the spelling on my opening slide. Obviously, I still need a little bit of education, but let's move on. Right, so the basic sciences have been defined as mathematics, physics, chemistry, and biology, with the NSTF suggesting that perhaps astronomy and earth sciences should be added on. I have a slightly different view. I think the basic sciences should be mathematics, physics, which includes astronomy, chemistry, and then the environmental sciences, which would include biology, geography, geology. But that's maybe just semantics. Africa, as we know, faces many educational challenges. Depending on which authority you use, there are between 2,000 and 3,000 languages in Africa. So for young people to be taught in their home language is quite a challenge. Africa has a large population, 1.4 billion people, which is about 16.7% of the world population, with a high percentage, 56%, living in rural areas. So reaching young people in rural areas through the formal education sector is difficult. And a point I will make later on is that I really think it's essential that when we talk about education, we should always talk about how the partnership between formal and informal education can be achieved, especially in Africa. Because our museums, science centers, and outreach programs can reach children in rural areas which schools have difficulty reaching. In general, there's a poorly developed formal educational infrastructure if you take the continent as a whole, and only 20% of eligible young children are currently enrolled in primary schools. Well, that's a figure from 2012, but it has improved substantially since then, but numbers are difficult to find. And so far, no African country has achieved universal primary education. So clearly there are challenges, but there are also many opportunities. Now let's take a few steps back. And it's interesting to look at how science has transformed itself. The original goal of science, as defined by the Royal Society of London, established in 1660, included the statement to subdue nature for the benefit of humankind. So, at that stage, people regarded themselves as sort of superior to all other living things, not necessarily dependent on them, and that people had the right to subdue nature for their own benefit. Even that great thinker, Charles Darwin, who developed one of the most revolutionary theories in the history of science, evolution by natural selection, after his visit to the Cape of Good Hope on the voyage of the Beagle in July 1836, and after he had been taken on a tour by Sir Andrew Smith around the Western Cape, and had failed to see the large antelope populations that previously existed, he wrote to a friend, the decimation of wildlife is an unfortunate consequence of human civilization. So that was the sort of the way people rationalized the decimation of wildlife at that time. Now, the modern goal of science is more informed and more nuanced. And from the environmental perspective, I define it as to understand natural phenomena and processes and learn to live within their limits. And it also includes allowing natural processes to continue at their normal rates. So if we take the example of extinction, our goal is not to wipe out extinction. That would be absurd. Extinction is a perfectly natural process, but to allow it to continue at its normal rate rather than escalate it as we have done. And I believe the particular role of the basic sciences is to provide a fundamental understanding of natural phenomena and processes and how to live within their limits. Because although humankind has been battered by various challenges of late, including COVID, which killed millions of people and over 103,000 in South Africa, the reality is that climate change and the threats to biodiversity and life support systems is a much, much more serious problem from which no one is immune. There's no vaccination, and it's going to affect every single one of us. So while there are other important priorities in science, learning to live within the limits of natural processes is one of humankind's biggest priorities. And keeping in mind that we are just one species of the 8.7 million plant and animal species that live on the planet. Now, I was interested in the questions posed by the International Science Program at Uppsala University. What is the justification for supporting basic sciences in low and lower middle income countries? Well, I personally think that's an absurd question, which smacks back to the kind of thinking that occurred in South Africa 20, 30 years ago. I think that the situation is that there is absolutely no reason why basic sciences should not be taught to countries with so-called low and lower middle incomes. The other thing, our question is, how do we classify countries? Maybe we should rather talk, instead of talking about the developed world and the developing world, we should talk about the overdeveloped world and the appropriately developed world. Because let's remember that in terms of climate change, almost all the causes of that have arisen in Northern Hemisphere, so-called well-developed countries. And Africa, which contributes least to the causes of climate change, in fact, stands to be impacted the most. So I think we need to relook at the way in which we classify countries. When we talk about low-income countries, are we including the value of barter, which is a massive informal trade in rural areas? Has anyone ever quantified that properly? And has anyone factored in the consumerism, rampant consumerism, which occurs mainly in so-called developed countries and is one of the main causes of climate change through its various ramifications on the environment. So, my view is different. I think many African countries were fortunate in that they escaped the worst impacts of the first three industrial revolutions and are now benefiting from the fourth revolution, which I don't think is an industrial revolution, but a post-industrial revolution, and I'll come back to that. And I think that the sustainable ways of life that have been developed in many African countries are in fact an example that the so-called developed countries in the Northern Hemisphere should follow and will be forced to follow in the near future. And then the second question, will support to basic sciences contribute to poverty reduction? Well, that seems to imply that poverty is the only problem in Africa and in other parts of the so-called developing world, whereas there are many, many other problems which need to be faced. And my view is that the circumstances in Africa, including the educational challenges that I've mentioned, mean it's even more important for the basic sciences to be taught in Africa. And I'll give some examples from my various books of why it is important. Now, as I mentioned, I've written a number of books on South African and African inventions, including those based on traditional knowledge. What a Great Idea is a comprehensive overview. Curious Notions, a series of essays addressing this topic. And most recently, Harambee, The Spirit of Innovation in Africa, which was the first attempt to provide an overview of innovation in the continent. And Harambee is a Swahili word meaning let's all pull together. It's the motto of Kenya. It appears on the Kenyan national coat of arms. And I think it's appropriate that Kenya has that motto because I regard it as one of the most innovative countries in Africa, although it may be classified as a low-income country. So, what we need to recognize is that Africa is not only the cradle of civilization, but I think arguably also the crucible of innovation. And these are just some of the Africa firsts. developed by earlier cultures, tool making, fishing, hunting, boat building, astronomy, mathematics, etc. Major contributions which laid the foundation for developments which occurred elsewhere. I'm just going to shoot through a few, and anyone who doubts that Africans are innovative must just take note of the vast number of innovations that have been achieved. Controlled use of fire, 1.1 million years ago. First evidence for this found in South Africa and Namibia. And that, of course, was an enabling technology which allowed people to keep warm, to produce light, to cook and preserve food, and to make tools, and to make tools that make tools. And our middens, which are basically the debris from the first technology hubs, there are over 3,000 of them around the South African coast, and all of them provide evidence of remarkable innovation by early inhabitants of the subcontinent. Homo habilis produced a variety of tools, starting in wood, shell, and bone, and then moving on to metal. And then we're all familiar with the earliest known abstract artwork in the world from Blombos Cave, the earliest known mathematical device from Border Cave, the lunar stick. And there are many examples that we know of and which I've written about of how indigenous knowledge acts as a kind of stepping stone into low, medium, and then high technology solutions to the problems that people face. And I think the fact that African people have faced so many challenges during their times, during their lifetimes, has made them problem solvers. Here's a simple example. Maize farmers in Zambia have problems with elephants trampling and eating their mealies. They have observed in nature that bees frighten elephants, so they put beehives around their fields. And that has now been elevated where even the recordings of the buzzing of bees and even aerosols that mimic the pheromones released by bees can be used to repel elephants. Another low-tech example, cattle farmers in northern Botswana had problems with lions predating on their cattle, and they had noticed that a number of animals, including insects and birds, use live eye spots to repel predators. So they did an experiment together with university researchers where they painted realistic eye spots on both sides of the rumps of their cattle. And they did quite a large experiment with 300 cattle painted and 300 not painted. And at the end of 3 years, not a single cow with an eye spot on it had been predated by lions. And there are many examples also of how indigenous knowledge has been beneficiated and taken to the market. Rooibos tea, infusions from it have been used as healthy drinks and infusions for centuries, but it took a German immigrant, Benjamin Ginsberg, who came from a tea-making family in Russia to take it to the market. And you can now buy many different forms of rooibos tea around the world. And the same can be applied to buchu, to products arising from kelp, products from aloes, etc. And all of these required the first people who developed these products, they had a basic knowledge of science and were able to use that knowledge to develop these products. And a great example of indigenous knowledge being taken to the market, the CSIR developed mosquito repellent candles based on the active ingredients in Lipia japonica, which is a plant that's traditionally used to repel mosquitoes. And if we look back on industrial developments, no one can argue that Africa is a backward continent, classified as low income and so on. James Greathead, a farmer's son from Grahamstown, now Makanda, immigrated to England, and he invented the apparatus that was used to drill the tunnels for the London Underground, and is known in England as the father of the London Underground. Percy Tucker developed CompuTicket, the first computerized ticketing system in the world by 18 years. And arguably South Africa's greatest inventor, Trevor Wadley, who had an extremely good knowledge of physics, electronics, and mathematics, developed not only transistorized and crystal-controlled radios, but his famous tellurimeter, which was a distance measuring device. And that was used for mapping the roads and railways of over 19 countries around the world, including Kenya. There you can see images of the tellurimeter being used all over the world, a world-famous invention for which he received many awards. The full range of radio and infrared tellurimeters that were made by a company, Telemat Plessy in Cape Town, and exported worldwide. So, and then, of course, our big industries such as Sasol, Petrosa, etc., have produced many innovations. So let's, I think the first point we need to make is that African countries have made a major contribution to science and technology in the world. They need to be regarded on an equal basis with the Northern Hemisphere. Our greatest, arguably the greatest invention with which a South African was associated was the CAT scanner, basically a three-dimensional X-ray machine, now used in every hospital worldwide. And it was co-invented with Godfrey Hounsfield, a biotechnologist in England. And like all great inventions, the CAT scanner gave rise to other similar inventions. One of them is Lodox, a low-dose X-ray machine invented by De Beers Diamond Mining Company to, as they said, to reduce the risk of miners using diamonds as a dietary supplement. In other words, reduce diamond smuggling. And Lodox is now used in casualty wards and in hospitals all around the world for quick X-rays of casualties. And another example, Kit Vaughan of Cape Town developed the Assesco breast imaging system, which is also a 3D X-ray. So these are, further examples of how the basic sciences have been applied in African countries to make useful products. A wind-up radio was first developed in England, but much more sophisticated and reliable wind-up radios, as well as torches and cell phone batteries, cell phone chargers were developed in South Africa. And that technology was taken further with the development of wind-up medical apparatus by Dave Woods and his team, like the pulse oximeter and the fetal heart rate monitor that can be used in rural clinics where there are no batteries and unreliable electricity supply. Henry Johnson, I had the good fortune to meet him. He was originally employed in the Navy, where he was a ballistics expert. And what impressed me about him was his extraordinary knowledge of mathematics, and especially of trigonometry. And he admitted that that knowledge and his interest in mathematics made his career possible, because he moved from the Navy, developing missiles and tracking their courses, to developing various tools for measuring the speed and trajectory of sports balls, such as a speed gun in cricket, in golf, in tennis. And he's now settled in Florida and makes world-class products, all based on his interest in and knowledge of trigonometry. And here's another great example of someone who took what I call the step ladder of innovation from indigenous knowledge up into high-tech solutions. Dr. Mutoni Masindi, she grew up in rural Kenya. Her father and uncles were all farmers, and she noticed that they made predictions about important agricultural events, such as when to sow the seeds, when to harvest the crop, based on observations in nature. And while she appreciated the value of its indigenous knowledge, she realized that sometimes their predictions were inaccurate. So she developed the Itiki drought predictor, which combines indigenous knowledge with modern meteorological data to improve the accuracy of rural farmers' predictions. And this system was so successful, she was able to complete a PhD at UCT, and she's now employed at the Central University of Technology in the Free State in South Africa, and continues to improve and implement the use of the Itiki drought predictor. Lucky Netshedzati, he had parents who were deaf and dumb, and he couldn't communicate with them. So he used his interest in electronics and robotics to develop a talking glove that converts sign language into voice and text. And Sandeli and Gopo, working with a team at the CSIR, and for his PhD thesis, was the first member of first team to develop a three-dimensional laser, digital laser, which is something that laboratories around the world had been attempting to develop for some time. We all know Mark Shuttleworth, our first African in space, who used his fortunes to very good effect by promoting innovation and developing various open source platforms like Ubuntu, Kudubuntu, Edubuntu, etc., to promote access to the internet. And then I mentioned Kenya earlier. M-Pesa was the first mobile phone-based money transfer system anywhere in the world, first launched in 2007 by Safaricom. And it totally revolutionized the way in which people who aren't bankable, in other words, who don't have enough assets to open a bank account, can trade and develop small-scale businesses. And the M-Pesa model has now been copied all over the world and is used not only for money transfers, but for microfinancing, and has really completely revolutionized the way in which African people can take their ideas to the market and be profitable. So, you know, many of the entrepreneurs we have in Africa are social entrepreneurs, in other words, people working in adverse environments who are developing products for the public good. And some of them are commercial entrepreneurs who are mainly profit orientated and typically, you know, make use of market forces to become rich. We need a combination of both of them, but Africa is particularly rich in social entrepreneurs. Many other products have been developed, Mama Money, which is another way of sending money home from the mines or from working in the city, and a whole range of these financial products have been developed in Africa. Henry Furetier is another example of someone who's used cell phone technology to benefit his particular business. He's a chicken farmer in rural Cameroon, far away from the services of any vet, but he developed the Save the Chicken app, whereby he could take photographs of any diseased chickens, as well as their droppings and their food and chicken coop, send them to a vet. The vet would then diagnose what's wrong and send through a remedy, and Henry would implement that and also spread the news to other chicken farmers. And this kind of smartphone technology, which allows unbankable people to develop industries in rural areas, is now being applied across agriculture, horticulture, animal husbandry, chicken farming, aquaculture throughout Africa. And it's sort of under the radar. And I wonder if the people who measure what the income is of people in Africa, whether they actually factor in these sort of transactions. Louis Liebenberg, a great example of someone who has a great respect for indigenous knowledge. He developed Cyber Tracker, which is a palm-top computer with a built-in GPS, in which he could record the knowledge of illiterate but very knowledgeable sand hunters in the Kalahari. And over a period of decades, he documented their knowledge. And like all great inventions, Cyber Tracker is now used by field workers all over the world to record field data. And interestingly, it has an icon-based keyboard so that the sand hunters using the pictograms in the keyboard can input data themselves. Of course, we can't take credit for all of Elon Musk's inventions, but he did invent PayPal while in South Africa, but he's gone on to other great things and has now been compared with Jeff Bezos, Bill Gates, and Steve Jobs as one of the greatest innovators in the modern generation. So someone we can be proud of, educated in Pretoria, obtained his basic education, his love of science and technology here, and has taken that much further in the USA. Lithium-ion batteries, the concept for them as rechargeable batteries, first developed by Michael Thackeray and Johan Kutzer at the CSR in the 1980s. Sadly, funds could not be raised at the time to take this extremely important product to the market, so it is now made elsewhere. But interesting, all the major manufacturers are licensees of the CSR intellectual property and have to pay a fee for the use of that property. Brian Gitter from Ghana is an example of an entrepreneur who came from a very humble background. He developed an interest in science and especially the basic sciences. And after years of struggle, developed the matoscope for the rapid diagnosis of malaria without needing a blood sample. Vehicles, South Africa has recently developed the hydrogen fuel cell forklift through Hydrogen South Africa, the University of Western Cape and Department of Science and Innovation. And Anglo American has developed this monster 2 megawatt hydrogen battery hybrid truck with a phenomenal payload of 290 tons per truck. So, no one needs to sneer at the innovation and the ability of African people to come up with solutions. I was amazed in my research to find that over 20 African countries have produced motor cars which have gone on commercial sale, although it must be admitted that many of these are government subsidized projects. Even Madagascar has produced Carenia Mazana, which is a rugged truck used in rural areas. One of our serial entrepreneurs is Mulalo Doyoyo. He also came from a relatively humble background, became interested in science and has developed a range of low and high tech products, including Cinacell, which is a cementless concrete, and Morigard, which is a paint made from waste material, and then the hydrogen motorbike and the biaxial universal testing machine. And of course, South Africa and other African countries are host to some quite phenomenal astronomy space science projects. So the South African Large Telescope, a large light telescope based near Carnarvon, and then the massive square kilometer array, a radio telescope project centered in South Africa, but with participation by several other African countries, as well as Australia. So we really are at the forefront of these aspects of astronomy. And many innovations have come out of SKA, such as SCARAB, the SKA Reconfigurable Application Board, which can continually be modified as new findings are made. And perhaps one of the most remarkable examples of African innovation based on knowledge of science and the basic sciences are the first internet in the sky balloon suspended internet towers, which are now hovering in geostationary orbit over Kenya at an altitude of 20 kilometers. And they were used as cell phone towers, internet towers, because Kenya is a very rugged, mountainous country, very expensive to put up physical towers. So they've rather used these balloons suspended in the sky in this remarkable way. Many people don't realize that no less than 19 African states have national space programs. Most of them are to put satellites in orbit so that they can monitor environmental changes on the ground. This is the example of an Ethiopian satellite. And I'm sure that some of the great innovators in African history would be amazed if anyone questions whether the basic sciences should be taught to young people in Africa. Wangari Maathai, the first East African woman to receive a PhD, she pioneered the planting of trees and the real awareness of the importance of trees in the economy of East and West African countries, and received the Nobel Peace Prize for her work, because of course there is no Nobel Prize for the environment. Tabela Nyakong at Rhodes University, who developed photodynamic cancer therapy treatments, is one of Africa's most productive and respected researchers. Also came from a very humble background. In fact, she and her brother used to alternate duties in the highlands of Lesotho, where she grew up, looking after the goat herd and go to schools on alternate days. But now she's doing world-class work as a result of her early interest in science and her early education in that field. And Professor Kelly Shabali from UCT and his team have developed a one-pill malaria treatment, which will revolutionize malaria treatment. So there are many South African and African innovators. All of them, I think, would support the view that Africa is the bright continent. Africa has so much potential to play, and we should not downplay its contributions. So let me make some basic comments about the basic sciences. I've seen in the documents that a comment made that teaching the basic sciences helps people to gain knowledge. I think it's much more important than that. It teaches them not only how to gain knowledge, but also to understand a natural phenomena. Learning about the basic sciences and the scientific method also helps people to learn about rational objective thinking, cause and effect. And it's amazing how many captains of industry are people with the scientific background, and they've succeeded because they understand the scientific method and they know how to make evidence-based decisions. Basic sciences also teach people to be skeptical, to acknowledge that science is always work in progress. It will never be achieve a full understanding of everything. And it's an important aspect of the scientific method that we constantly challenge the status quo. We challenge the knowledge of our elders. We challenge the knowledge of past generations. And we recognize that science advances not only by standing on the shoulders of giants, but also by kicking their feet out from under them. Knowledge of the basic sciences helps young people to develop a skill set that will make it easier for them to succeed in the modern world. And it helps them to climb what I call the innovation stepladder from low to medium to high tech, which is a characteristic of innovation in Africa. Knowledge of the basic sciences also helps to develop wisdom, in other words, knowledge that can be applied to make good decisions, as well as a positive mindset and an appropriate behavior and lifestyle, depending on your particular circumstances. And then to take that even further and influence others to become ambassadors for a positive mindset and appropriate behavior and lifestyle, which is particularly important as we contemplate our impact on the natural environment and how we've got to rationalize our lifestyles and live within the limits that nature has imposed. I've developed a concept called the education value chain, which I've mentioned in the previous slide, that it's not enough for us in formal and informal education to just convey information. Most people have access to information. We've got to take it further than that. We've got to communicate knowledge, in other words, information contextualized within the life circumstances of individual people. We've got to go further than that and use that knowledge as wisdom to make wise decisions in terms of our own circumstances. And that would hopefully lead to changed mindsets, changed behavior, and influencing others to change their mindset and behavior. And if we can all become ambassadors for that education value chain, I think it will go a long way to help us solving the problems that we face. So I'd like to make another point, and that is, I believe that science is under threat today, almost as much as it might have been in Galileo's day. The social media and the internet provide a megaphone for fringe groups at the either end of the bell curve to make known their anti-science and pseudoscience sentiments to a wide number of people. And it's quite remarkable how many people are gullible and accept this incorrect information. It is also remarkable about how many cultures and peoples around the world do not believe in some of the basic concepts of science, which we believe in. I spent, excuse me, about 5 years living and working in the Middle East, and there people either do not or not allowed to believe in concepts such as the value of the fossil record, radiocarbon dating, evolution by natural selection, continental drift. I can't understand how people can appreciate biodiversity and appreciate the biological sciences without accepting the theory of evolution by natural selection. In South Africa, informal surveys have revealed that more than half of rural teachers do not believe in evolution. Surveys at the cradle of humankind have shown that an alarming number of people do not accept some of the basic concepts of science. So I think one of the biggest priorities we have in our formal and informal education sector is to emphasize the value of science and make people realize that it is one of the main tools that we have to solve the very challenging problems that humankind and all the other inhabitants of the planet face at this time. Just a few reasons why I believe it's so important for people to appreciate the value of science and have a knowledge of the basic sciences. Firstly, it promotes evidence-based decision-making. And that is really the only way of making good decisions. It also recognizes the triple bottom line. In other words, that the environment is just as important as financial and social good. It takes us beyond individual decisions and bias. It encourages groupthink and consensus and guards against authoritarianism. And this is very important because we've seen many examples, for instance, in authoritarian countries where pseudoscience is carried out and can create some very misleading conclusions. Science and its bedfellow technology have greatly increased our computing power. We all know about Moore's law, but it has got a downside in that in some cases too much data is being produced, and some people suspect that we already have the data to answer many big questions. We just don't know it yet because we haven't analyzed that data. Science and technology accelerate technology take-up, and this is a feature of Africa, where my research has revealed that there's very rapid technology take-up in Africa, and considerable technology leapfrogs, accessing the internet and using cell phone technology. So once again, although Africa may have missed most of the benefits of the first, second, and third industrial revolution, it's certainly not missing the benefits of this fourth revolution. And being involved in science, especially with access to internet and cell phones, also promotes international collaboration. It reduces the isolation of people working in rural areas and facilitates collaboration across cultures and countries and continents. It also promotes citizen science. There are millions of citizen scientists in Africa, people who are not qualified as scientists, but who are practicing science at different levels. Henry Ferretia, the chicken farmer, is one of them. And there are many, many other examples. And this is something that I see absolutely booming in Africa with the number of citizen scientists. And we need to recognize the value and the importance of their contributions. Science and technology have made the world a better place. Peter Diamandis, in his revolutionary book Abundance, published in 2016, indicated that over the last 100 years, our lifespan has increased twofold. And in fact, over the last 300 years, it's increased threefold. Cost of food has dropped by 13 times, cost of energy 20 times, cost of transport 100 times, and communications over 1,000 times. So there's no doubt that science and technology have improved the quality of life of humans. The question we must ask is, to what extent have they also improved the quality of life of the other inhabitants of the planet on whom we depend for our own existence? And perhaps most important, science helps us to be humble if we recognize what science is, and that is that it's work in progress. We don't understand things, we're still striving to understand things. It helps us to know our roles and responsibilities, recognize our shortcomings, and acknowledge our ignorance. Now, the basic sciences and sustainable development is the theme of this seminar series and of many other activities of the NSTF. And I'd like to go through my thought process in terms of the environmental crisis. Humanity is at the crossroads. We're the most numerous large animals ever, and our ability to manipulate the environment is unprecedented. We've exceeded the planet's ability to compensate for our action. And in particular, we've exceeded the planet's ability to provide us with the resources that we need to survive. And it's been estimated that at our current rate of resource use, humans would need 3.6 planets in order to survive, and we only have one. We arose from and survived through a biological process, but we are no longer part of wild nature, or that's what we think anyway. We are servants of our machines trapped in unsustainable urban environments, and we are the first animal to domesticate itself and to lose its ecological place. Now, we must realize that other animals, if they lose their ecological niche, the consequence is usually extinction. We are an integral part of nature. We are a valuable species, but not a superior one from the ecological point of view. Every living thing has a right to live, or at least to struggle to live. And this right is not dependent on its actual or potential use to humans. This right is dependent on the ecological roles that they play in the biosphere. Now, our role, as per the modern definition of science, is to understand and work in harmony with nature and not to conquer it. So we have evolved from hunter-gatherers to pastoralists to shopper industrialists, and now we're information fetishists. What we should be evolving towards is custodians of the biosphere. And our dilemma is that the thinking that led us into today's problems will not lead us out of them. We need to unlearn what we learned before and overcome the cultural and economic constraints that were crafted during the industrial era using new techniques and the fantastic new tool sets that are available to us now. Now, the famous economist, Dr. Klaus Schwab, who started the World Economic Forum, he's predicted that the world will be characterized by disruption, upended economy, societal norm challenge, and I don't think anyone disagrees with him. He's also proposed that we're in the fourth industrial revolution. And it so happens that although I'm little more than a retired fisherman, I disagree with him. I don't think we're in the fourth industrial revolution. I think we're in the first post-industrial revolution. Now, of course, it's a Western conceit that all the industrial revolutions have taken place in Western countries, mainly in Western Europe and North America. But in fact, there were many previous industrial revolutions, and probably the most significant one was the so-called golden age of science in Islam, which lasted from 850 to 1492, which laid the foundation for many of the discoveries and innovations in the European industrial revolutions. Now, the first three industrial revolutions, which took place starting in the late 1700s, the middle 1800s, and then the early 1900s, they did generate many benefits: economic development, job creation, technological innovation, massive development of products and services, improved infrastructure, globalization, which is a double-edged sword, advanced medical care, etc. But you'll notice that all of those are benefits for one species, Homo sapiens. None of them, or very few of them, have benefited the other species on the planet, on which we depend for our own survival. We also need to recognize that these industrial revolutions created problems. They encouraged a very materialistic culture, conspicuous consumption, overpopulation, not only by humans, but also by their domesticated animals, inequality and poverty across social communities worldwide, pollution of land, sea, and air, biodiversity loss. And remember, biodiversity loss also means the loss of the ecological interactions between species and the ecological services that species provide, such as providing potable water, fertile soils, pollinating fruits. Greenhouse gas emissions, climate change, human migrations, and natural resource shortage. So, I argue that while those first three industrial revolutions had benefits, they also created massive problems which we're facing today. And that this first post-industrial revolution is a completely different kind of revolution. It's not just a continuation of incremental industrial development. It has a completely different personality. And this post-industrial revolution gives us a chance to drive a new, bigger and better step in human progress, redress past imbalances, adopt a less materialistic culture, and develop a more sustainable way of life. And you may remember I mentioned earlier that the rest of the world has a lot to learn from Africa about sustainable living. So African practices are now in the forefront of people's thinking. And we've already witnessed a number of digital revolutions, moving from carbon-based power to distributed renewables, internal combustion engines to electric vehicles, broadcast and print to internet and robots, capital, labor, and land, which are the measures that are still used in the West to measure wealth, are being replaced by data and knowledge, big banks by smartphones, ownership by rental, the post office by courier and drones. And all of these actually play into the hands of countries that largely skipped those first three industrial revolutions, but are taking full advantage of the first post-industrial revolution. So why is this a post-industrial revolution?
Right, I'm not sure if I'm frozen or whether Prof Mike Bruton is frozen.
Democratize the technology, once again, playing into Africa's hands. So,
Mike, you just broke up a bit there. You froze a bit. Could you just repeat the last two sentences, maybe?
Oh, okay. So I'm saying, why is this the first post-industrial revolution? Because it's characterized by us having a set of digital tools we never had before. It's very disruptive and changing the way we're doing things. It's a form of social intervention and social domination that facilitates technology leapfrogs and democratizes technology. So it's playing right into Africa's hands. So I argue that it's not just semantics, we're not just playing with words. This fourth post-industrial revolution requires a major change of mindset. It may even be regarded as anti-industrial or post-industrial. It's not characterized by smoke billowing from chimneys owned by rich white men. It's characterized by millions of tiny gig economies run by women and men of different cultures in different continents. It's capable of undoing the wrongs of the first three industrial revolutions, and it's an opportunity to harness resources in an unprecedented way to solve global problems. And the important thing about this post-industrial revolution is that it's carried out by a multi-brain, multi-generational superorganism with a collective genius and a group intelligence, which can co-create solutions to the most intractable problems. And the important thing about it is the internet, which not only connects us, but entangles us in an unprecedented way. And not only connects people, but connects us with the Internet of Things, which is providing very useful data to make predictions. So I argue this is not just another industrial revolution, it's a connecting problem-solving post-industrial revolution, and which we must take full advantage of its opportunities. And Africa has a very strong role to play because of the rapid technology uptake in Africa, the technology leapfrogs that have been experienced here. And all of this to me just emphasizes the absolute importance of educating young African people in the basic sciences so that they can go up that step ladder of innovation and develop innovations of their own. What's usually to our advantage is that the so-called demographic dividend, the average age of humans in Africa is 17.9 years, compared with 38.1 years in North America and 44.1 years in Europe. So we have a huge advantage of young people coming through the system. So in summary, therefore, Africa, I see this as our century. There's rapid technology uptake, massive technology leapfrog, strong social and commercial entrepreneurship, a step ladder of innovation, and a community that has failed often enough and got up and started again so as to be unafraid of failure. And I'd like to end with a comment on the importance of informal science education facilities. Obviously, what happens in schools, colleges, and universities in the formal sector is very important, but we have to marry that with the contributions of the informal sector, education sector, such as science centers, museums, information centers, etc. The traditional definition of a science center is an educational facility that facilitates use of the most effective methods to teach science and technology. My definition of it is as a safe place for dangerous ideas. The number of science centers in Africa, unfortunately, pathetically small. In the whole of Africa, there are only 59, and 34 of those occur in South Africa, 58%. So we can be very proud of the network of science centers which we've developed, but Africa as a whole is very poorly served, and almost all of them are in the extreme north or the extreme south of the continent, with very few in West and East and Central Africa. And there's a view across the Cape Town Science Centre, which is one of the science centres that I've helped to establish. They are really wonderful tools with pooled resources which schools need to make full use of, both on site and through their mobile science centres and outreach programs. They complement the school curriculum, they don't compete with it, and they play a major role in nurturing curiosity and inquisitiveness. The importance of play is emphasized in science centers, where playing is probably the most important thing that children do. It's the first draft of life, and they learn so many important concepts while playing. They can learn about Bernoulli's principle in physics. Can learn all sorts of things to do with momentum and gravitation, and environmental and geographical sciences are taught in science centers. Many aspects of physics, electrics, electronics. Chemistry is also taught there. There's someone learning about rockets, logic, mathematics, very important in science centers as well. One of my recent projects was as first director and founder of the Bahrain Science Center in Manama City, Bahrain. There you can see it. It's a wonderful facility that established through the Department of Social Development, which I think is a very appropriate department for a science center. And there you can see many of the different activities being carried on. And we received extremely positive feedback about the contribution of this science center to the education of young people in the sciences and technology, especially the basic sciences. Another example, learning about magnetism, and a magnificent interactive display on sustainable living. So, I'd like to appeal to everyone to recognize the value of the very extensive science center network in South Africa, and hopefully this will also develop further elsewhere in Africa. And then to end with a few comments, you might remember in 2016, there was a bit of a revolt among students at UCT where they said that, you know, we need to get rid of Western science and teach African science. Well, in my opinion, there's no such thing as Western science or African science. There's only one science, and that's something to which all humankind contributes. But of course, the African contributions to science, and it's extremely important that more of these are included in our curriculum, because if you look at the curriculum, virtually nothing that was achieved in Africa is mentioned there. Indigenous knowledge, I see it as a complementary knowledge system that complements science, and the two have a lot to learn and benefit from one another. And, you know, we really need to emphasize in our school curricula the African contributions to science and technology, make us not only as proud as Africans, but also recognize, you know, how much we've achieved. And then lastly, I think it's extremely important that we have to bring science into the mainstream of society. We need to make it as exciting to young people as music and theater and dance and sports. That is the case in some other countries. We haven't achieved that as yet in South Africa. So thank you very much for listening, and I look forward to any questions. Thank you.